Hello everyone, myself Ahad Sheikh, and I am Electric Vehicle Research Associate at Elite Techno Groups, and I will be conducting this particular webinar. So, can some of you just mention in the chat box if my voice is clear or not? Okay, sure. Thank you so much, Ivan. So, yes, I will present my screen and we will get started. Yes, I hope my presentation is also visible to everyone.
Yes, sir, it's visible.
Yes, sir.
Okay, well, thank you very much. So, once again, welcome to all the attendees of the webinars. Our topic of this particular webinar is electrifying your ride, which is electric retrofitting basically. And here we will see what is an overview of this webinar, what we will be going to see throughout this webinar. So first of all, we will talk about the current environmental issues which the entire globe is facing, then what are the solutions to those particular issues, and if the for that particular issues we are considering electric vehicles as a solution, then what challenges we are facing to adopt the electric vehicles, and what is retrofitting and why it is needed and how it is related to electric vehicles, then what are different types of retrofitting, what is the process for retrofitting, and some vehicles real life examples that has been done, and who are the manufacturers for the retrofitting kits, what are the pros and cons, and who should go for EV conversion. So these are major highlight will be the major highlights of today's webinar. So starting with current environmental issues, being an engineering student or any background, we have already studied in our school, like in our EVS subject, environmental studies, that the globe is facing the pollution, and the major part of that pollution is air pollution, right? And that air pollution, we all know the major contributor to the air pollution is electric automobile tailpipe emissions, harmful gases that comes because of burning of fossil fuels inside the engine. So these gases include carbon dioxide, carbon monoxide, and nitrogen oxide, NOx, and all. So these gases, they are very much harmful for our environment. And if you see total emission from the transportation sector, so major contributors are passenger cars and commercial vehicles. So the around 70-75% of the pollution is done by the emission of automobiles only. And these emission majorly include carbon dioxide, which entraps the heat to the earth's surface, and it increases the temperature. It is increasing the temperature of the earth. So that term is called global warming, right? That global warming is a result of excess of carbon dioxide in the earth atmosphere, and that global warming is resulting in drastic climate changes, and we all are facing different climate change issues nowadays. I assume that all of you are aware, like the weather today In past few days also, we can see it's raining. It's November, but yes, it's raining in some parts of India. So yes, that climate change is a real thing, and we are facing it now. And can I just know how many of you from Mumbai? You can just mention in chat box if you are from Mumbai, because I have something to discuss regarding the Mumbai's climate. Okay, so yes, we don't waste much time for this. Uh, if you are from Mumbai, so you may have heard the recent news from the South Bombay's air quality. So this is the article from Times of India that tells the South Mumbai's air quality worse than Delhi's. So for people who are from Delhi, uh, they already have very poor air quality. Air quality index of Delhi is always above 350, which is very poor. So South Bombay is also facing similar situations. So yes, Mumbaikars, be ready for such situations also. And here I have mentioned a QR code for the Central Pollution Control Board's website. If you scan it with your phone, you will be directed to a PDF where you can see the air quality index from 17th of November of almost all the cities of India, or maybe major cities of India. So you can check whether you are breathing which kind of air quality. So here you can scan this particular QR code. So moving further, we'll talk some more details about the climate change exactly. So we are facing the extreme weather conditions in multiple parts of the world. If it rains so much that the flood situation occurs, right? And if it's a summer season, then temperature goes beyond 50-degree, and somewhere where it never happened to be that cold, temperature goes below 0 degree Celsius. So yes, we are facing major climate changes all around the globe, like lightning situation in Mumbai and all. And we are also seeing the melting glaciers from the North Pole, and this is resulting in rising of sea levels. So yes, that also causes the flood situations. And do you guys know about acid rain? How does acid rain phenomena takes place? And basically, what acid is present in acid rain? Does anyone has any idea about that?
If the pH value is about 5.6, then it is known as acid rain.
Yes, definitely. And can you just mention if you know what acid is present there in acid rain?
Sulfuric acid.
Yes, fantastic. So yeah, because of sulfuric acid present in the acid rain, you can see that its effect on the Taj Mahal's marble, that it's getting yellowish, and it also affects badly to the trees, plants, and living beings also. So yes, these changes are real. And so, what you guys think? What could be the possible solution? Means from an automobile perspective, what solutions we have, or automobile sector has given us to tackle these particular problems? What are your points? What are your notes on this? You can mention in the chat box, or you may unmute yourself. Stepping in electric vehicle. Yes, that's the solution. One of the solutions. But what about except electric vehicles? Uh, Running our conventional IC engine vehicle, what solutions are possible? Means what we have already implemented, that also you can mention, and what we can use, that also. Yes, renewable resources are definitely one of the solutions, right?
Catalysts have been used in silencers.
Yes, catalytic converters. And any more things? Means that's from the emission point of view. We can control that after burning the fossil fuel, right? Those are the things. And we also can control what can be put inside the engine. From that perspective also you can think these are only two phases where we can actually make changes to reduce these things. Yes,
Using good
Exhaust
octane.
gas recirculations.
yes, definitely. Right, adding ethanol more in petrols. Yes, the emission
Using
from,
good octane number fuels.
pardon, I didn't hear that, please.
Using good octane number fuels like
Yes, good octane
around
number.
200.
Hmm. Hydrogen as a fuel, yes, great. So moving to our next slide, we will see what are the solutions automobile manufacturers have provided us so that we can reduce these emissions. So research and development in the field of exhaust gas treatment, after treatment system to reduce the harmful emissions. So yes, one of you mentioned exhaust gas recirculation system. So this is the schematic of how does it works. The exhaust gases in the exhaust manifold are directed to the intake manifold and they are reused. So this circulation takes place. So that's why it's called exhaust gas recirculation. But still, we have not eliminated the complete. We have not completely eliminated the harmful gases. We are reusing it, but some most of amount of it gets emitted to the environment. And we can also talk about emission norms that governments put to the automobile manufacturers, right? Like our government has uh, pushed hard on emission norms. We have directly jumped from BS4 to BS6. So this is also one of the steps to reduce the emissions. And this is the this is how catalytic converter works to reduce the emission. And as I mentioned, we can also think about what goes inside the engine. That part also we can think to modify in order to reduce the harmful emissions. So yes, we can opt for CNG LPGs. CNG comparatively gives less harmful gases, and biofuels also, like biodiesel and all, but each of them are somehow they result into the emission only. It's not 100 completely eliminated, right? Biofuels also are not completely a solution because we cannot directly use it in our engine. We have to blend it with a fossil fuel with some percentage decided by the regional government. Then only we can use in our engine. Then ethanol also, it requires special type of engine modification. And then talking about the hydrogen. So hydrogen is something which is used as a fuel. Okay, maybe there was a network crash from my side. No issues. So ultimately, we are coming to the electric vehicles only. If we go to see the 100% pure solution. So yes, we can say the electric vehicle is the solution, not the complete solution. Yes, there are points that includes that adds to the pollution somewhere, like manufacturing of batteries, extraction of chemicals to manufacture those particular batteries. Their part, these part are already contributing to pollution, but this so did I just disconnected?
Yes, sir.
Okay, sorry, where were I? So yeah, let's continue with this slide only. So if we think electric vehicle is a solution, uh, then also we have some challenges. So what could be the challenges in adoption of EV? First of all, we can say almost everyone knows that charging infrastructure is one of the challenge in adoption of electric vehicles, because as of now the era is changing, means it's just a transition period from IC engine vehicles to electric vehicles. So um, as of now we have less number of electric vehicles on road, so that's why charging manufacturers are also taking it as a risk to manufacture charging station. And from the buyer perspective, buyers thinks that we already don't have any charging station nearby, right? We don't have that much of infrastructure for charging station, so then why would we buy EV? So it's like of game happening, like what came first, what should come first, the charging infrastructure or the EV? So that's battle going on. Yes, that's also the challenge. Then next point is cost. Yes, EVs are costlier than IC engine vehicles, and major contribution in the cost of electric vehicle is battery itself. It's cost around one third to the half of the vehicle, depends on what kind of battery is chosen and what range it provides. So cost is one of the challenge. Then the transition phase, from shifting from IC engine vehicle to directly electric vehicles and skipping hybrid vehicles. So this phase is also taken as a challenge. Then what about if people try to purchase electric vehicles? So what will happen to their old vehicles? This is also one of the challenge people think about. Then from manufacturer's point of view, it's new production techniques, like under the chassis everything is different in electric vehicles. So they have to set up a new production line, new production techniques, new assembly lines. So these are the challenges in adoption of electric vehicles. So also have to find out the solution to these particular challenges. And there is one concept that addresses most of these challenges. Like, except the charging infrastructure part, all other challenges can be taken care of with the help of the concept electric retrofitting. Yes, electric retrofitting can provide solution to these challenges, right? So let's talk about our today's main topic, electric retrofitting. So what is electric retrofitting? Does anyone of you have any idea what is electric retrofitting? Yes, you can mention in the chat box or unmute yourself. Engine to motor and run as EV by some modification. Yes, that's great. You are correct answer. So yes, we can say it's a conversion of IC engine vehicle into an electric vehicle. Yes, that can happen, and that's legally allowed by our government. Like, other modifications are not allowed by Indian government, but this particular thing our government has accepted, and we can do this by law. Conversion of IC engine vehicle into an electric vehicle. So this is a retrofitting. So first of all, we will talk about why retrofitting is a solution. So we can see we have already talked a lot about environmental issues, global warming, climate change, and also we won't do that again. Uh, we can say public needs. So if people get aware about electric vehicles and how environmental friendly these are, so people will demand mostly electric vehicles, right? So if demand increases, we need to fulfill the public demand. So that's why we can do more retrofittings. And also we can say it's a low investment, because purchasing a new electric vehicle is way costlier than converting your conventional vehicle into an electric vehicle, right? And it also increases the vehicle life cycle, because if you think your vehicle is getting old and you want a new vehicle but you want to get electrified, so yes, you can go for electric retrofitting also. And talking about um, scrappage policy that our government has introduced. So if government takes a strict action against the old vehicles, so what will you do? Will you dump your old vehicle in the scrap, or would you like to make it work um, with on electric driveline? So yes, that's definitely nobody would want. Means if you own a two wheeler, right, and you like, means most of the bullet owners, right, they have 90s vintage model to them. But if government takes strict action against those particular models, they say that you are having a vehicle way old and it produce lot of emission. So you have to definitely go for a fitness test, and if your vehicle fails, you have to dump it into a scrapyard. So nobody likes that. But what you can do is you can retrofit your vehicle and run it on the charging electricity. So these are some reasons because of what we you can go for retrofitting, like. And yes, if we are talking about the retrofitting, we must mention what are the types of retrofitting that can happen. So first is hybrid electric retrofitting. So what happens in hybrid electric retrofitting? The driveline existing driveline of IC engine vehicle remains as it is. We add supplementary electric driveline to it and make it hybrid electric vehicle or plug-in hybrid electric vehicle. So basically, electric drivetrain assists the IC engine drivetrain in start-stop conditions, or maybe sometime cruising conditions also. So yes, this is what hybrid electric retrofitting is. Then full electric retrofitting is removing all the IC engine related components and adding electric vehicle related components to it to make it a pure electric vehicle. Like you can see here, this is one of the example of retrofittings. This conventional Splendor, Hero Splendor, is converted into electric Splendor. You can see this hub motor here, in wheel hub motor fitted over here, and they have covered the battery pack and controller part with this panel. So this is the conversion from IC engine to the electric vehicle. Um, but if we talk about hybrid electric retrofitting, so yes, it's majorly not advisable because of particular reasons. The one reason is that particular vehicle is designed to balance the weight, curb weight or cross weight of that particular vehicle. Uh, its engine and other components are designed to bear that weight only. If you add battery pack and motor and all other components related to EV, so it will increase the weight. So definitely it's going to result in the low efficiency. And that doesn't make any sense of retrofitting, because retrofitting, if you are doing retrofitting, you must get some advantage in terms of efficiency also. So if you go for hybrid electric retrofitting, the efficiency drops, and it the driveline becomes complex. It already have IC engine drivetrain and you are adding electric drivetrain to it also, then yes, it becomes complex to design that particular system. And the instrument cluster also becomes congested. You have to put some indicators to see the battery percentage, voltage, and safety parameters of the battery, range, kilometer range, all that thing. So that instrument cluster also becomes very congested, and also dynamics of vehicle gets affected. Some reasons are unbalanced weight distribution. So whenever a vehicle is designed, the weight distribution is taken care of. Our components are placed in such a manner that load divide load di- load division on the front axle and rear axle is according to the dynamics of that particular vehicle. So that weight distribution get disturbed if you add heavy batteries and motors to that particular vehicle. And also the hub motor. So hub motor increases the unsprung mass because it's after the suspension system, right? So it's not advisable to have the more unsprung mass from the vehicle dynamics perspective. So yes, it definitely gives the poor vehicle dynamics. So that's why hybrid electric retrofitting is majorly not advisable. So if someone wants to go for fully electric retrofitting, so how that can be done? So there are some pre-checks that need to be have before retrofitting. So first one is you have to see to the calculation part. Means you right now you have this performance of your particular vehicle, and if you convert it into electric, what performance it will give. So that part you have to take care of. Then you have to see the chassis and body must remain undamaged, because if you are retrofitting your vehicle but chassis and body are already in a damaged condition, so it won't last long, right? So that doesn't make any sense of retrofitting. So that part must also be taken care of. And the major thing is reversibility. Once you go for electric retrofitting, then there is almost no coming back to IC engine vehicle, because you make so many changes in the vehicle structure. So if you are not satisfied with the performance or the handling of the electric vehicle, retrofitted electric vehicle, so you shouldn't think about coming back to the IC engine vehicle in that particular model. So that thing you need to care about. Otherwise, if all these points are not making any issue, so you can go for electric retrofitting. Then now we will talk about how it is done. What are the steps for retrofitting? So first of all, you have to see what are the current specification of your vehicle, and what are its performance, like mileage, and if it's a hybrid, you have to see. No, hybrid vehicles are not converted into retrofitted electric vehicles, but pure IC engine vehicles are only done. So you have to see the current specs of your vehicle, and you have to finalize the expected performance, what you want from that particular vehicle, how much of range you want there, and what should be the maximum speed of the particular vehicle, what initial torque that vehicle requires. So these particular things you have to finalize first. Then you have to do the component sizing. Component sizing is, if you have finalized the maximum speed, range, mileage and all, so you have to select the particular battery pack, a particular motor to be installed, and the controller and other power electronic systems. So you have to do the component sizing. Then you have to select the architecture for that particular vehicle, what architecture you are going to follow. The You will put the motor in the front or in the rear, and what orientation will you follow, it will be transverse or longitudinal, that particular thing. And once you have decided all these things, then you go for removal of IC engine components. Then you see what are the available space there, and then you install the electric vehicle components safely, which includes hardware and software, because yes, it's electric vehicle, right? So it will definitely have more number of electric parts in it, and which are controlled with the help of softwares. So you have to see to it. And the last thing comes is making connections, necessary connections, and giving it a test ride. So these are the steps followed for retrofitting. We will see it in more detail here. So like I mentioned, the performance part. So yes, study the IC engine performance, what power of engine is fitted there, at what RPM it gives the peak torque and peak speed. Then finalize your performance parameters, what speed you want, and make sure that the your performances are um, either the same or they are enhanced in the EV variant of that particular vehicle. Then only it will make sense to go for retrofitting. And comes the component sizing part. Component sizing, as I mentioned, you have to finalize what kind of battery, means what capacity of battery you will be using there, and according to that you have to select the motor which will give the necessary initial. Uh, did I just disconnected? Okay, I'm really sorry for that. Can some of you mention wherever I?
Right from component sizing.
Okay, okay, sure. So yes, component sizing. Component sizing includes the design of battery pack, selection of electric motor, motor power, and maximum torque, RPM. All these things is included in motor sizing. Then transmission model is also there. So first of all, road loads are calculated based on the weight and yes, weight of the vehicle. That includes rolling resistance from from the drive perspective, and then gradient resistance, aerodynamic drag, acceleration force. All these forces are calculated and added to find the total tractive effort. Then it's converted into the initial torque that requires. All these things are called chassis model in terms of designing. And these from the chassis model, we design a transmission model where we select the suitable gear ratios, and we also define the motor model where we put details of particular motor specifications that we have decided to install. These are found in motor model, and then we select the suitable battery model there, where we add the specification of uh, battery pack chemistry, voltage, cutoff voltage, peak voltage, nominal voltages. So these things are included in battery model. And one of the main thing is cell selection. So cell selection is done on the basis of these six criterias. The very first thing which is considered is higher specific density. That particular cell chemistry must store maximum number of electric charges in a per kg of weight. So that's what specific energy of that particular cell is. That needs to be very high, and in order to reduce the overall weight of the vehicle. So that has to be taken care of. Then comes the safety perspective. Safety perspective is something, how does that particular cell chemistry responds to the external environment. If say that particular cell gets damaged because of crash and anything, so how does it react? Does it catch fire, or just it gives some sparks, or it doesn't burn? So that things are needed to be seen. Then comes thermal stability. So if that cell is operated in this particular range, so what is the response of that cell? Can it be operated above 30-40 degrees Celsius? If yes, then only those cells are suitable to be used as a battery pack. Then low voltage and high current systems are seen. Um, for this particular point, we can say low voltage is recommended because to gain low voltage we need less number of cells in parallel, and if we put more number of cells in parallel, so it becomes difficult to balance those cells electrically. So low voltage system is recommended. So that needs to be seen before selecting the cell. And also the packing efficiency. Packing efficiency refers to the geometry of that particular vehicle. So there are three types of cell forms: cylindrical, prismatic, and pouch cells. So which of those particular cells give higher packing efficiency, that needs to be seen. And more especially the number of cycles, how many for how many charge discharge cycles that cell have. So that needs to be seen before selecting those particular cell chemistry. So all these things come under the component sizing. So this is the major thing that has to be done before while retrofitting the vehicle. So these are core engineering terms and core engineering field to be work on. Then comes the architecture of the vehicle. So once you happen to remove the all IC engine related components, then you have to think of what architecture will be suitable for that particular vehicle. So as most of the cars in India and globally also are front engine front wheel drive. So many people and many companies go for front wheel drive only, and which is exactly the compact and efficient way of doing the retrofitting. Then comes the rear wheel drive. So if front wheel drive is not possible, means there is no enough space to put the motor and all. So also rear wheel drive can happen. And in different segments like light commercial vehicles and all, there we see front engine rail wheel drive system. So after EV conversion also we can keep that front engine front motor rear wheel drive system, but it's kind of low efficient because of the propeller shaft that comes in between. It reduces the efficiency, transmission efficiency. And all another reason is that electric vehicles provide way higher torque than IC engine at lower RPMs. Means from 0 RPM itself, electric vehicle gives above 100 Newton meters of torque, and so it may damage the propeller shaft in the starting condition if we give that high torque. So if it propeller shaft it is designed to bear that particular amount of torque, then we can go for rear front motor rear wheel drive also, but front wheel drives are recommended basically. So uh, if the next step will be removal of IC engine vehicles. So can you people mention what components can be removed from the vehicle? Yes, you can mention in the chat box or unmute yourself. Means if I say take this particular model and we have to go for retrofitting of this model. So what components will you remove from there? Yes, I see many replies. Okay. So yes, definitely engine will go out, then transmission system. Yes, engine coolant system also. Think about all the components that are linked to the engine, and they are not required in the electric driveline. Okay, so mention those parts. Yes, radiator is required, but not for lower powered motor. Yes, but for battery pack cooling, there might be a radiator, right? Yes, fuel tank, correct. So we will see. Most of you have mentioned. Now, see if you have mentioned.
Exhaust system.
Yes, definitely, because there is no exhaust. That's the issue, man. That's the exact issue of IC engine vehicle, the exhaust system. So, and that is the point where electric vehicles takes leads. So yes, we will talk about more. First of all, IC engine will be removed. Definitely, we don't want that. And then clutch comes. After IC engine, there is a clutch in driveline, and we don't need clutch because uh, majorly electric vehicles don't have a transmission system. So we also don't need clutch. And what along with clutch can you mention? Clutch also has something linked to it. So what cannot be there with the clutch? Anyone? Flywheel definitely will not be there if it's
Clutch
engine.
pedaling.
Yes, exactly. The clutch pedal, because there is no clutch, so why would you need a clutch pedal, right? So clutch pedal will also go along with the clutch. Then uh, then comes gearbox. As I mentioned, mostly there is no gearbox. There is no need to shift the gears because electric motors gives very much sufficient range to operate. From 0 RPM itself, it gives higher torque. So definitely we don't need gearbox. And what along with gearbox, there is something that is connected to the gearbox. So that also we need to remove.
Gear shift mechanism.
Yes, gear shifting mechanism, right? So that will definitely go out. And then comes the fuel tank. Again, there is something that is linked to the fuel tank. So that's the fuel line from where fuel comes in. So that will also be removed. Yes, these are some minor points, but definitely they adds to the weight of the vehicle and they will be removed. Then comes the air filters under the bumper. We don't need any air filter because we don't require any air intake for electric driveline. Then the exhaust system, as you guys mentioned, and what more can you think of that needs to be removed, especially in diesel vehicle? So there is a uh, fuel added in the diesel vehicles.
Fuel pump.
Yes, CI pump. Yes, so everything that is in contact with engine and that is not of any mean to the electric driveline, that those particular parts will be removed. Then we will now talk about what all components will be added in electric vehicle. So yes, you guys can mention what EV components we can add. Yes, DEF, diesel emission fuel.
Battery controller motor.
Yes, battery control motor. These are main parts of the electric vehicle. Yes, DC-DC converter. BCM. Uh, BCM, you mean battery control module? Actually, it's a BMS system, battery management system.
Battery management system.
Smaller smaller cooling system.
Yes, definitely. If you analyze that battery chemistry gets heated if it's run beyond certain limits, so you have to add cooling system to the battery. And if motor temperature also rises, then cooling system for motor is also needed sometimes. So we will see one by one what components can be added into an electric vehicle while retrofitting. So yes, battery pack, and there is an extra auxiliary battery also to run the other auxiliary electric components. The main battery pack will just control the powertrain, but for other components like headlamps and instrument cluster systems, infotainment system, telematics, door handling, windows, and all. For these particular things, we have to put auxiliary battery like we have in our conventional IC engine vehicle. Then comes with battery, we have to manage the charging and discharging of the battery. We need to have the battery management system, which is a vast topic in itself for the electric and electronics perspective of the battery. it is considered as the backbone of battery pack, because if you don't manage the particular battery electrically, so it becomes very much hazardous to the passengers life risk basically. And then battery thermal management system also, like one of you mentioned, there has to be battery thermal management system, cooling system. Like we have radiator in our IC engine, so here also we add radiator or some similar cooling mechanism. Then comes AC-DC converter, DC-DC converters, which are majorly called as power electronics part, that controls the electronic flow and all. Then comes the our uh, propulsion unit, electric motor that propels the vehicle. So that will be added. Then motor controller to control the motor RPM and all. We have to have motor controller also. Then to feed the electric charge, we need to have charging port, onboard charger, and the last but not the least, bus bars. Bus bars are nothing but the wiring system, high voltage and low voltage wiring system to connect all the electric components in the vehicle. So these all components will get added while retrofitting of a particular vehicle. So yes, moving further, we will see some examples of retrofitted vehicles. Like here you can see the model, which is Swift Desire, and it is converted into completely electric vehicle. And you can see the specification for this particular model. It has 15 kilowatt of motor, which gives 170 newton meter torque, initial torque at 0 rpm itself. Then it has a 15 kilowatt of battery that gives 250 kilometer of range, which is quite good, right? And when it was converted, it was observed that the overall weight of the vehicle is reduced by 3 kgs. Initially, it was 950 kgs. Now it's 947 kgs. So it depends on the component that you select and how much efficiently you have sized your components. So it sometimes reduces the overall weight, and it may sometimes increase the overall weight also. So yes, it depends on the engineering of that particular retrofitting kit. Then one main thing here is it has 5-speed manual transmission. Yes, I mentioned earlier that generally electric vehicles don't have multiple speed transmission system. It runs on the um, gearlessly, because motor electric motor provides sufficient RPM range for torques. So there is no need to add a transmission. But this particular company have added 5-speed manual transmission so that the driver gets the feel of conventional IC engine vehicle. uh, can someone of does anyone of you know what which electric vehicle has um, multi-speed transmission system? Because generally Tesla cars don't have, right? Tesla cars don't have any gear shifting mechanism, but there is one sport electric car which is provided multiple speed transmission system. And anyone if you mention that? Yes, two gear, right? Which model? Which model? Okay, don't remember them. No issues. It's Porsche Taycan. Porsche Taycan has two-speed transmission system. So yes, electric vehicles do have multiple speed transmission system, like most of the electric commercial vehicles, trucks and all, and also some buses also, electric buses. The electric motor present in those particular vehicles are also not sufficient to provide the enough torque. So there has to be added a transmission system to fulfill the initial torque requirement. So yes, in heavy vehicles, there are transmission systems. And the second thing here is this is light commercial vehicle, Tata Ace model. and you can see it is converted into from IC engine vehicle. Initially, IC engine has to be placed here, right? This is where IC engine was there, but now they have put the electric motor. This axle is converted into E axle, and they have put the electric motor over here. So yes, this is also the example of conversion of IC engine into an electric, and this is the most popular segment, right? Light commercial vehicles are the most popular segment for retrofitting. We will see that in our upcoming slides. So we will talk about who are the retrofit kit manufacturers in India, because I don't know how many of you were aware of retrofitting before this particular webinar, because if we talk about electric vehicle, people think about like Tesla and BMW I series and all, and ZSEV, Nexon. People only these models come into mind, but we also have concept of retrofitting, and this particular field is booming right now, and it will definitely uh, get to its peak when our government takes strict action against the old vehicles. So this field is going to be uh, very much popular in a automobile sector. So we will talk about what are the Indian startups that provide retrofitting services. So the first one is Atrio. Startup actually, Atrio, and they provide very much. Uh, Actually, their customers are very much satisfied with their kits. They have very positive reviews on the EV platforms. They have converted um, Wagonar, Swift Desire, and Tata Ace also. And then there is this cell propulsion, which is founded by the ex ISRO alumni. ISRO, uh, what you say, ISRO employees, ex ISRO employees. This particular organization was founded, and they have converted Tata Ace model into an electric model, and they are they are providing their best service for this particular model. And there is this Pune-based startup, Northway Motorsport. Uh, they have also converted Swift Desire into an electric model, and they claim to have 250 kilometers of range. So yes, there is a competition going on in this field also, and this is all. And here also you can see the Go A1. This particular startup has also converted the very popular in India Splendor into an electric Splendor. They have fitted the hub motor over here on the rear wheel, and the battery pack and controller are fitted here. So yes, this gives very much better performance than Splendor. Also, Splendor is famous for its mileage, right? And you are going for electric, so it definitely gives more number of kilometers per rupees. So yes, this is very more economical than the our conventional Splendor Plus. But there is this thing about two-wheeler retrofitting. Like we are having, uh, we can say nowadays Ather, let's say Ather or Ola Electric, they are providing um, good electric vehicles, good two-wheelers in less amount. So in two-wheeler segment, we can say the price of EVs has reduced, and subsidies are also provided by our government, state government also. So majorly the EV policy for Delhi government is considered as very good, and from some South Indian states also. So yes, state governments are trying hard to um, push the electric vehicle, and they are serious about the EV mission. So yes, it's better to purchase new two-wheeler to get a retrofitted, because the for this particular Splendor Plus, it cost around 40,000 and somewhat more than that to convert it, and that also gives just 80 kilometer of range. But and if you want more range, around 150 kilometer like that, so the kit price goes about 95,000 rupees. You can see this in on their website. I have done this research. So in 95,000 you will get a new electric vehicle, two wheeler, electric two wheeler. So yes, these are some points that need to be considered before going for retrofitting. Yes, but it's very much advisable for light commercial vehicle sector. Okay, so there are pros and cons of this concept also, like each concept. But uh, what we can say in pros is, yeah, if you don't want to scrap your vehicle, you want to extend its life, you want to use it more, so yes, you can go for retrofitting, and it's the best solution rather than scrapping your vehicle. Then yes, it's a step towards the e-mobility mission, towards the green environment friendly mobility. And yes, it is a long term money saving concept also, because if your vehicle, as your vehicle gets old, it starts consuming more fuel for per kilometer range. So, and if you talk about electric vehicle, its running cost is way less than IC engine vehicles. So in long term, maybe initial investment could be high, but in long term, you will save your money. Then talking about the cons, sometimes yeah, retrofitting goes a little costly. But as I mentioned, if you see from long term perspective, it's definitely money saving. Then maintenance part comes. If like now this particular concept is new, and if you have retrofitted your vehicle from a particular uh, company, and that company don't serve in area that you live in, so you have to go there and call them for maintenance. The general mechanic, local mechanic won't touch your vehicle, because if it's electric and it's fitted from someone else, so yes, that's an issue. Then comes the battery pack replacement. Means after several years, let's say 3 4 years, generally they provide 3 years of warranty, 2 to 3 years of warranty for the battery pack. But in case something happens after that, then it becomes very costly to replace the battery, because the part major contribution in the cost of IC engine vehicle is battery pack only. So yes, we can say these are some cons of the retrofitting. So should everyone go for retrofitting, or there are some particulars who should think of going for EV conversion? So we will see about that. So the first thing that can come is LCV owners. So those particular drivers who runs the light commercial vehicles like Tata Ace, for example, which is very popular, Chota Hathi we call it. So it if they have a diesel variant of it, so it definitely produce, diesel vehicles produce more harmful, more emissions that than petrol vehicles, and diesel prices are also increasing day by day. And as their vehicle gets older, it gives less mileage, means ज़्यादा पीती है basically, and the engine efficiency also drops. So if they think, if yes, the retrofitting is solution for those particular LCV owners, so they can extend life of their vehicles. And then delivery service providers like delivery and whoever the grocery delivery services, those people can go for retrofitting of their delivery vehicles. Then taxi or auto drivers also, because they just roam around some range of kilometer every day, so they don't go for a long ride. So if there are some drivers, they can think of retrofitting their vehicles, because yes, it gives more number of kilometers in less money. So yes, there it will be good for them. Then sharing mobility services like Ola and all, so yes, they can also take initiative in retrofitting their existing service vehicles into an electric vehicle, so that our India can get electrified earlier than other countries. So yes, these are particulars who should go for EV conversion, and also passenger car owners also go for EV conversions, as we have seen in previous examples. So yes, this was it for today's webinar. We have seen starting from environmental issues, then we talked about climate change conditions, and not just Delhi but Mumbai is also facing climate change conditions, and that air quality index and all. Then we saw the solutions from auto manufacturers to tackle those problems. Then what challenges are there in adoption of EV? Then we talked about the retrofitting, how it is done, different types, and why hybrid retrofitting is not advisable. Then what is the process involved there, and we focused majorly on component sizing and the architecture selection. And yes, you guys gave very much responsive answers in component removal and addition. And also we saw various examples like Swift Desire, Tata Ace, and all. We also saw the various kit manufacturers. Then we looked at the pros and cons, and then we who should go for EV conversion and all these things. So if you guys have any doubt in this particular webinar from the start, you can mention, or maybe some points you can add to it.
No, sir, no
No, sir,
doubt.
no doubt.
Okay. Yes, if you are means you people are from engineering background and thinking of electric vehicle related projects, so you can also think about the conversion process. Means not I won't suggest that take a vehicle and remove all the parts and make it electric. That will definitely not advisable. But you can from design point of view, you can select any component. Like if you select, as I mentioned, light commercial vehicle is a popular sector for EV conversion, right? And most of the like Amazon and all delivery services, they are adopting these conversion kits for the delivery vehicles. So you can think of a particular light commercial vehicle, and you can go with the design part of it, like designing or component sizing for that particular vehicle. What battery can be selected, what motor can be put there, what kind of transmission we can have there, if we can have multiple speed transmission like that Swift Desire example. So you can think on these particular points also from the final year project point of view. And also if you are willing to work in electric vehicle industry, so yes, this is also one of the domain to be working in, because as I mentioned, this is just an emerging field, right? And as if Indian government starts taking action strictly on the old vehicles, like 10 years for passenger cars, heavy duty vehicles, and 15 years for passenger vehicles. So if we take strict action, there will be a number of plenty of means plethora of vehicles in the junkyard, right? So the people definitely means generation that mm, uh, our above generation means our father and all, they love their car way much, and they don't want to scrap their vehicles. So yes, people with those kind of thinking will go for EV conversion. So this field will rise in future. So yes, you can think of working in these startups also. So for those particular things to work as an in electric vehicle field, whether it's retrofitting company or it's a pure EV manufacturer company, you definitely require skills, right? And for those particular skills uh, to acquire, I don't think the automobile engineer engineering syllabus is capable of providing those skills. So we have our internship courses on our website. So if you go through our website, so here you can see internship courses in vehicle dynamics, machine science, data science, machine learning, artificial intelligence, and we have electric vehicle sector also. So as of now, we have three courses, and this electric vehicle design and development course, this gives the very much in-depth idea of how electric vehicles structure is and how it is designed. So just have a look on this. So when you opt for this particular course, you will get an international course certificate, which is valid all over the globe. Then we conduct live sessions bi-weekly or weekly with the expert, and there you can have one-to-one interaction with experts also. Then we also provide letter of recommendation to our best performance. We have quizzes after every video lecture. So if you perform well in the quiz, you will get a letter of recommendation that will definitely help you in higher studies and all. So there you need letter of recommendation if you go for abroad for universities or in India also. Then we also work on industry based projects. So I will show you further. Then we have, as I mentioned, doubt sections are there, dedicated support system is there. Then yes, this is virtual, you can watch it in your phone, tablet, PC, anywhere, and it's flexible according to your time. Then if you opt for this particular course, you will acquire the skills that a battery design engineer needs in the industry. Then also related to battery thermal management system, also EV powertrain engineer, you can work as EV safety engineer. So the skill required to be such professional in this field, we are providing in this particular course. Okay, so what skills you will acquire are electric vehicle architecture, as I mentioned, selection of the suitable architecture for the vehicle. Then what are the safety protocols? EV electric vehicle needs to be designed um, from the safety perspective also. Then thermal and current monitoring. Battery design is the way popular field in EV domain right now. Powertrain sizing and battery properties, heat management system. These are research and development areas. So you can work on those domains also after acquiring these skills. Then here are some certificates we have mentioned. Complete after completion of this course, you will get certificate. Then there is a project report also, and for, as I mentioned, for top performers in the our quiz contest and all, we give letter of recommendation. Then you will see who will be conducting those particular internships. So here are our industry experts. We contact with the people who are already working in those particular field, who are experienced in that domain, and they help us to build this particular internship programs for you. So these are this, and some projects also. Basically we uh, put projects which are most relevant in the most manner to the real life situations and examples. So you can see development of mathematical modeling and design lithium ion battery system. So you design a particular lithium ion battery for a particular model, you will be provided some data that this is the vehicle weight and all, and the voltage system, and you have to design a battery pack for that particular vehicle. So these are some project highlights of this particular course. And here you can see the detailed course content, what topics we have covered in each module of the course. Like if you say mechanical design, so what is energy storage system? They are different, like fuel cells, ultra capacitors are also there. Then in detail study of lithium ion batteries, what are types, what are different technologies, battery chemistries and all. then C rate and how does it affect the battery performance, what C rate should be selected for that particular drive line. So yes, these are some major highlights of our basic to expert EV course. So I am pasting a link to discount also those who have attended this particular session um, on this platform. So uh, just hold on a second. I will put. Meanwhile, you guys can mention if you have any doubt or any discussion you want. So here I am putting a feedback form link. So just go to it and fill this particular feedback form, and there you will be provided with the uh, so discount code and all. And also I will mention here also. No worries. So if you apply this particular code coupon um, and 21, you will get 60% discount on these courses, and it's valid till tomorrow only. So you have to hurry, go to the website, check out the content, see the ratings. Um, so if you have any query, any doubt related to the course or the webinar, or you just want to discuss something about retrofitting, you can mention. This is Madhusuthan asking, can we do low speed EV without any RTO process? Uh, as per my knowledge, if your vehicle is below 25 kilometers hour of speed, 25 kilometer per hour, so you don't need any kind of RTO processing and all. No registration is required. If it's above that, then you have to register to the RTO. So yes, you can go for low speed if it's within 20 kilometers per hour speed. Yes, here I have mentioned the feedback form. I will put it again if you need. How retrofitting details help to build a new EV. Yes, you retrofitting details, you design a battery pack, you select a suitable motor. So that's what new EV making procedure has common, right? There is also battery pack selection, motor selection, and all driveline sizing, powertrain sizing. All these things are also there in new EVs. So yes, just the body and chassis remain the same. Otherwise, everything is similar to electric vehicle only. So yes, these are common parts in retrofitting and new electric vehicle. Yes, if you have filled the feedback form, so you guys can leave for today. And thank you very much for attending patiently. Um, Go to our website, see to the courses, and keep learning, keep exploring. I am here for more few minutes if you have any doubt, any queries, or you may leave. Yes, Subhash. Um, yes, as I mentioned, for passenger car owners, EV maybe they can have double thoughts about that, but for LCV owners and taxi auto, I think my connection was interrupted. So yes, as I mentioned, some hybrid hybrid retrofitting is not advisable. So in similar manner, for if it's costly and you want more range, so definitely cost will go high. If you travel more than 100 200 kilometers on your daily basis, so it's definitely not advisable for that for those particulars. But if you travel only intracity, this retrofitting, you are definitely learning the building of electric vehicle only, and that's the future of mobility.
Okay, sir.
So from that, uh, okay then, thank you so much, and best of luck for your studies.
Thank you so much, sir.
Thank you very much. Welcome.